So what I'm hoping today is to talk to you about some of the key aspects of what CICD are. You know, there's a bit of a buzzword that float around in the industry. We do a lot of DevOps consulting at Cevo, and people think that's pretty much coming in and installing a Jenkins server and walking out the other side. Realistically, it's fundamentally a completely different approach, and there's a lot more about the way you prepare your work, the way you drive the work, the way you deliver it, but it also connects a lot with process improvement, setting up opportunities for experimentation. So when you go through what I see CICD to be, a number of good aspects that really sort of describe what good behaviour in that space looks like. So trying to separate the two into two actual parts and look at what are some of the key aspects. So we're not going to dig into the technology, we're not going to talk about actually how you would build this and how you would set that up. If that's what you're looking for, give me a call. We'll talk you through a little bit of a model that we use on how we get there. So, you know, unless we're measuring things, how can we improve them? So giving a bit of a roadmap on where we get from either a small or an inefficient CICD practice up to something that's much more robust and resilient. And of course, we should be always connecting back with the business benefits on this. So how are we connecting the effort that we're actually going to invest into something that's valuable for those beyond the technology teams? So let's start at the top. CICD, we sort of combine them together. They're sort of, you know, ubiquitously thrown around as one concept. I think one of the big challenges there is that when we couple the two of them together, we sort of miss the uniqueness of what these two aspects of the workflow look like. So continuous integration is much more around continually validating the state of that code base through automation. And it's really importantly driven from version control. So we'll come back to a little bit more on some of the aspects that are really important around what that happens. But really what this is the first step of the workflow. So getting the activities that are happening in that development team repeatably occurring and continuously integrating. So, you know, if we roll back 10 years ago, before this was prolific everywhere, what we would end up with is engineering teams that would have laptops, or no, they would have desktops 10 years ago, you know, all independently working together, building their own work for potentially days, weeks, in some cases horribly months at a time, and only at the end bringing these together into these integration cycles. We know we need to break that cycle because actually the biggest problem that I'm going to have with my code base is not my code, it's probably going to be somebody else's, because we're trying to move faster, we're trying to experiment faster. What we actually need to be able to do is get feedback from each other. So keep thinking that continuous integration is not just continuous and not just integration, but integrating continuously with ourselves, with each other. And then we move into CD, and so now it's up to you on which way you want to call this, continuous delivery or continuous deployment. But this is, now that we have something valid, something that we know is good, how do we then get that out in the hands of our teams, our customers, our influencers? So doing this in a repetitive way. Integration, delivery and deployment are really, they're like vectors that have the same direction because their goal is actually the same. So they're strongly aligned around us actually being able to produce value faster, make the process more robust, and give us greater confidence in what we're doing. If we can do things more frequently with a higher level of confidence, then we can do things more frequently, we can experiment more frequently, we can get faster feedback, we can start to deliver value to our customers better, we can experiment quicker. So delivery versus deployment. I've never really done continuous deployment. In large scale systems, the continuous deployment may be the GitHub model. You know, if it passes all of the checks and all of the workflows, it automatically deploys to production. Mostly in my view, I've worked around continuous delivery. So continuous delivery is the ability to release continuously to production, but done where there are still some stage gates, approvals, workflows involved to allow you to do that. Really, when we talk a lot about, you know, this is a lot of automation. I really like to start to talk to teams about augmentation versus automation. Teams will set out on an automation workflow and think about trying to automate from start to finish. Well, actually, we need to start thinking about is augmentation to start with. And that's where the pinnacle may be to head towards a continuous deployment approach where if I merge to master, magically it flows through into production in the utopia land. But a lot of times we can get stuck there using the 80-20 rule the wrong way, focusing on that last 20% of value, when really, if we actually just had a couple of steps in there, a couple of manual checks, a couple of reviews, we could do that in 15 minutes and we could still get the value into production in hands of our customers. So let's take a quick look at what good looks like with a subjective word. So these to me are the three key aspects that are really important to delivering good CI. Fundamentally, what we want to be able to do is decouple each of the individual components. So in a workflow, in application design for a long time, we've built large monoliths that have been a big, chunky application that has had all of the features and all of the functionality and all of the capability built into that. And what we've learned is, over time, it impedes our ability to feedback, it impedes our ability to iterate, it impedes our ability to incrementally deliver value because we have a big thing that we're not confident in changing. That approach, we talk about breaking things down into microservices, into microliths. That also applies to our CI process. So what we should be looking at trying to do is, how do we make sure that we decompose the phases of a CI workflow into unique, discrete, deliverable activities that are really that allow us to be able to change things out as things evolve. We also want them to be highly repeatable. Well, that's obvious, right? But not just repeatable as in they can continuously happen, but repeatable in relation to the versions of the tools that were actually used to generate that artifact, the version of the environment in which that CI was performed. And really importantly, that it's repeatable between the remote end, so often you'll run CI on a CI server somewhere centrally, but you also want the ability to be able to run that locally. And I heard someone describe this the other week as local and remote parity, which I thought was a really awesome way to describe it, that everything that the CI tool can do, you can actually do yourself. So let me give you a bit of an example of what that looks like in the real world. A lot of you, if you've done any CI work, will have probably played with tools like Jenkins or BuildCard or other things. And what you'll often end up initially is you'll install Jenkins and you'll go through the interface and you'll click your way through and you'll write this really big script on checking out a piece of code, running some linting across it, maybe doing some pre-generation steps, doing a bit of validation on those artifacts, a compilation, and then maybe some unit tests. A lot of the time, that script will end up in Jenkins. And there'll be a lot of things that will end up becoming organic in there, of parameters that need to be passed through to turn features on and off, or flags that need to change. How do you run that same test before commit to ensure that you're going to have a level of confidence that it's going to work on the CI tool? So we've started to go back to old school things like makefiles. I know it's horribly scary that we're back in tab-based makefiles, but using makefiles as strong interfaces between our local development toolkit and our CI toolkit, and give them a common entry point. Make install, make build, been around for a long time. Let's start to use some of those patterns. But then we've got to go another step further, but the version of the tools that we've used, and the versions of the environments that we've worked with, and the versions of the dependencies that have been brought into the tooling, how do we manage those? So along comes Docker. Now all of a sudden I can have a local Docker container that's got all of the tools in it that are given it a certain version that I can run locally. I can mount my local volume into that, make sure the application compiles against that specific version of the JRE or that specific version of some other dependency, and have a level of confidence that my CI tool can do the same thing because it will use those same Docker containers to be able to check those out. So repeatability not just within the CI workflow, but across the spectrum. And if we go back to the first point of decoupled items, it does mean then that I can run stage 6 or 7 of my CI workflow on my local machine because I know that's the bit I've changed, versus running a big monolithic script that goes all the way back to the start. Because what we're actually trying to achieve is the third point, which is the ability to fail fast. So if I run a CI tool workflow that's going to take 7 minutes for me to run, the chances of me running it as a local developer are probably approaching 0. I'm more likely to push that code to Jenkins and have it run. Now, in my world, that's actually the right way to do it. Like, let the computers wait for you, make them work. We can throw compute power at scale at them. But it's also optimizing around the wrong problem. If the wrong problem is it takes 7 minutes or 12 minutes or 15 minutes to do, when actually all I've done is change something that happens at stage 6, How do we make sure that you can just run stage 6 because you're an intelligent developer and you've got an idea of what it is that you're trying to achieve to get the fast feedback that you want, that I haven't broken anything horribly, and then we put it back into the CI flow for the machines to automate fully. All of that is about trying to reduce the cost and cycle time in what we're doing. So in the CI workflow, we're talking about unit tests. There's actually a picture. This is Martin Fowler's picture of the test pyramid. But there's actually a whole layer of tests before unit test, even in my mind, around what a compiler might do for you to ensure that the code meets syntax, to be able to do linting and validation checks on some of those some of those activities. And there's another set of tests as we move further and further up that stack. Things become more and more expensive. They take longer and longer to do, and so they start to violate those fundamental principles of the fast feedback cycle and decomposed components. So CD is the process of taking those artifacts, right? So we've got a known good artifact. Now what we need to be able to do is shift it through the pipeline. The hard part is our systems are becoming much more complicated. No longer do we actually have an artifact that is just the application, is just the code base. We actually end up with the infrastructure is now code. Our configuration is now code. And our data is now code. So how do we bring all of those together? So what we sort of have now in this CD flow is we have a number of upstream assets which all have their own CI lifecycle. So we have a CloudFormation template in AWS that is opening up some security ports that are required for some connectivity to the new part of the application. Well, we need to be able to validate that that artifact itself is valid and correct, that it meets the syntactic requirements of CloudFormation, that it's known good. Well, then we need to be able to write the application to be able to listen on those ports to have that. And maybe we need to be able to inject some configuration for it to say how will that application use those components. In a lot of systems, those artifacts are managed sometimes by different teams. Maybe they're managed at different life cycles. As we're starting to decompose those components, we actually end up with a different workflow up on the CI side. The tools that we'll use to validate CloudFormation versus a Java application versus a Go application versus some sort of YAML configuration will be radically different. The steps in that, the people potentially available to author change to those assets will be radically different. But it's only when these all combine and come together to create the CD process where we take copies of those and promote them through the system. So make sure that we're designing with the system in mind. So your CD workflow needs to understand which components will change and how frequently they will change and how well are there dependencies between them. This new piece of configuration requires this version of that application because the configuration won't match. Well, there's no point in being able to deploy out that new infrastructure unless the application is ready to consume those assets. So this builds on the concept of fail fast from the CI aspect. So what we want to be able to do is incrementally gain confidence as we move closer to production. In most environments, our production environment will be large and expensive and have a lot of moving parts in it that become relatively prohibitive for teams to be able to do earlier in the flow. So what we're trying to validate in those earlier integration environments or dev environments is really around the functional aspects of the system. As we begin to progress things forward, what we're looking to try and do is understand how scale and how high availability and how real data sets start to evolve. Now, if we can abstract all of that back into the CI and we can build good behaviors early and get that fast feedback, more power. But there's a lot of work often taken to do that. Thinking about augmentation and not full automation is how we will need points in which humans are going to be involved. So we want an environment in which we can put latest changes as quickly as possible to get our robots to bash the crap out of it and give us fast feedback. But we also don't want to do that in the middle of where our test team are actually executing progression tests or a series of expensive regression tests, even if they're automated. So having that separation between environments, ensuring that there's a level of consistency on what the activities are that get promoted through is hyper important. And that leads to point 3, which is the one I love the most, which is globally unique versions. So every time you build an artifact, you should version it. It should be immutable. We shouldn't change it ever again. Version 1.3 of that application should always be version 1.3 of that application. But version 1.3 of that application needs version 62 of the configuration, and it needs version 94 of the infrastructure. And how the hell do you actually manage all of that? I've got a whole workflow on that, which is another talk. but trying to create globally unique versions. So actually create a wrapper that wraps around all of them. So every time one of these upstream artifacts changes, keep those versions and tag them globally. What you can then start to say, well, is version 55 of our platform is in dev, and version 22 is in prod. And I can then start to see if that's done through version control and version controlled properly. I can then start to see, well, what are the differences? Well, the only differences between production and dev is 47 changes to the application. So if we're going to do a deployment, the risk here is there's no infrastructure change, there's no CloudFormation change, there's no config change. And then I know which versions of the application artifacts were actually generated inside each one of those global versions, and can come back and diff those and go, well, the only things that were actually changed were these 55 backwards and forwardses on some CS that we're arguing with the creative team on. So then the question would be is, do I need to test it? What am I trying to test? Do I need to do a full functional regression test of all of the finance features and the activities that do batch processing overnight? Well, hopefully not. Hopefully we can use intelligence to look at that and say there's a 3-week regressive automated, exhaustive regression suite. But because we have full traceability, because we have confidence in the way the change flows through the system, we can actually eliminate a large amount of cost from the system. So a full flow looks like this. You've all probably seen, a CICD flow where the humans are involved at a review stage to make sure that the change is actually what we're expecting. The JIRA ticket says we're changing the login form. Why have you made changes to the payment controller? That's the review stage that no CI is going to ever pick up for you. That's going to tell you, hang on, what you intended to do and what you actually did were different. We ran our unit tests, our integration tests, analysis, assemble and package and publish those artifacts. So the green layer there is the CI. And that runs over and over and over and over and over again on all of the different assets you have. And if you're running a microservices architecture, you've probably got thousands of those repos. And now we start to get into orchestration, where we bring those together and we start to promote those artifacts up into the environment, run out the deployment, run the functional testing, run UAT, and hopefully eventually at the end of that, after every single change, we deploy to production. The reality is that's not true, but we try to get there. The aim is to get there as frequently as we can. The next question is really how do we get there, right? How do we track where we're at? How do we know where to start? And how do we know we're actually making progress? Because as with everything, if we're not actually investing time in measuring what's happening, how will we know we're actually making progress? So we created, typed this table a couple of years ago, actually. I think there's a couple of new iterations of this floating around. And this is an approach. It doesn't have to be the approach, but this is one approach that I would say to look at. So what the aim of this is it works from a lot of the fundamental principles is if we actually measure things and we visualize those things, the conversations around them will be highly powerful. So the asset itself isn't as important. Similarly, if you're running, a Kanban or something, the actual cards on the wall probably aren't as important as the conversation that's had around them. The information that it conveys on how we're progressing and what's blocking us and what's holding us up and where are there opportunities for improvement, that's really what this does. So each environment that we've worked on, the columns here, headers change a bit because it depends on the type of system that you're working on and where the pain points are, and maybe there's a relatively mature part of the system already that's available, and so you can condense these columns. But looking at this, trying to get this in one view, to think about this from the start of what's the clarity around are we building this and how it's working, into the validation, and then moving into through the deployment. But also really importantly, the aspect here is to try and centralize this across lots of teams. So you can take the heading and do something like this and put it in one team's wall. But what you'll miss is the conversation and discussion that happens when you come here and you say, hey, I'm team B and we've got our infrastructure, our application, I'm team A, sorry, and we've got application as code done on our application B. Team C are looking to initiate that. Where do they go to talk? Who can they ask? We're trying to solve that problem. Instantly, you've got an idea here of where there are opportunities for sharing and reuse and collaboration. And in a much more evolved version than this one, you'll end up with lots of those little arrows saying this is an area that the team currently has focus on. And so mini huddles can actually happen across teams trying to solve those problems. It gives you a great piece of information radiation to say, where is it that I can go and look for help? where have people solved this problem already. So use some prioritization frameworks like weighted shortest job first to look at the effort that will be taken to close the gap and versus the return that we're actually going to get. But importantly, think globally but act locally. So if you come from enterprise space, you'll know that they're very good at setting up enterprise governance groups around the improvement of these things, who will want to go away and spend months writing documents on what a good unit test strategy should look like before ever having actually implemented one. One of the things I think this maturity map helps do is it allows teams to innovate themselves on their own to solve their own local problem, but creates a forum in which they need to be able to publish that globally for interaction. So if you're an engineering manager or you're working in teams that are responsible for sort of driving out some of this quality, how do you share that? How do you collaborate? Where's the knowledge repository that teams that have solved this problem can pour back into? The one advantage you've got in most cases is all of this will be code. So the ability to see the implementation and see the detail and probably even see it actually operating is probably 2 or 3 hyperlinks away. The challenge is not the 2 or 3 hyperlinks. The challenge is what's the location in which people go to look to see that information. Do you run showcases across teams, not within teams, but across teams showing this off? Do we only ever talk about the value that we're delivering to customers, or do we actually talk about the way that we're improving the process and the quality that we've received out of this? So as we move further through this workflow, we get into unit testing and shifting left. Is that actually still a thing? I don't know. I sort of say it like it's an empty statement, shifting left. But if we go back to the first step of CI is let's make sure that we have local and remote parity. So these are some ideas of places you could start. So let's look at unit testing as one of those places. It's often one of the big holes that we have in our application. In some places, what you'll find is a different group of engineers to those that are actually writing the code are charged with writing tests, be those functional tests, functional regression tests. Hopefully in most places that we're writing actual unit tests, the developers are actually writing those unit tests. But in some of the locations that I have seen this being done, where there is that split between the groups building the tests and the teams building the code, which is the horrible anti-pattern. One of the biggest things that holds them up is the ability to execute those tests locally. So they're built to run against a certain environment that has certain configuration. Again, this is up the stack. People writing functional tests, not unit tests. But even some of the unit tests not having the right environment set up, or the developers not doing it, or the tests run for a long time, there's no way to segment them easily. So make sure that you can run them locally and that you can segment them up. So there's a bit of an ego war at times with engineers who can, whether it's Vi versus Emacs, developing in Notepad++, please don't. Invest in a good quality IDE. Tradesmen use nail guns now. They don't use hammer and nail for a lot of stuff. There is, power saws versus hand saws. It's not an ego contest anymore to be really efficient with key bindings in Emacs. Let's invest in great IDE support. And the first thing you'll get super value from is code generation and generation of test stub frameworks to start with, but you'll also get the ability to be able to run tests repeatably in much smaller sets. We talked about consistent entry points, so making sure that the local to remote parity is really there. So invest in Makefiles or Gradle or other tools that you can actually run locally that have a high level of repeatability that can run into CI. And work on building a unit test execution flow on pull requests. Really powerful piece of feedback here. So make sure that your bots are commenting on your pull requests to say that the tests have been successful. You look at most open source projects in GitHub have got really strong Travis CI integration to exactly give you that feedback. Even going steps further into code inspection tests, so running linters and syntax checkers on the application themselves. Security inspection is a massive piece that people are probably not doing as well at the moment. Again, if you've run any GitHub projects, you'll notice in the last 12 months that they've started to do dependency analysis on your projects and provide feedback where there are known failures and known vulnerabilities in the platform. and code coverage. So again, talking to my GitHub experience, running things like coveralls and coverage tools across yours, feedback. Using all of that metadata to feed into, are we getting the right feedback? Are we keeping our code hygiene high? And the thing that probably most teams need help the most on when they're moving to a fuller CICD workflow is centralizing the artifacts. So if you don't separate the two, if you don't recognize that there's a strong delineation between the CI workflow and the CD workflow, what you'll be most inclined to do is probably build the artifact and deploy it all as sort of the same job. And that works at least for the dev environment. But then when you need to take that artifact and promote it forward, where is it? Do you go back into the old Jenkins job or the old build flow and pull that out and promote it upstream? Do you just take what was in that environment and copy it up? I goddamn hope not. So recognizing that flow of multiple artifacts flow now together to create our systems to be able to progress things forward, it's really important that we actually, keep these around. So take something like Artifactory or Nexus or S3 or something where you can store those persistent artifacts and push them through. But make sure that only things that are valid survive. So don't promote artifacts. If you do have to promote an artifact into a repository to somehow test it, maybe you do, work hard to be able to delete them out afterwards if they're not valid. In most cases, try not to leave the flow unless they're known good. But importantly, build it only once. So that comes back to that unique global immutability. Build it once, label it, tag it, it stays forever. Docker files and containers are really a great way of doing that, give you a nice encapsulation of all of the environment aspects that go together, and then those images just get promoted along the pipeline. So why do we do this all in the first place? That's the fundamental question. So none of this should be news to you. Fundamentally, it's the reduction of delivery risk. Without a flow, an automated-based software flow to drive things to production, we either rely on the human knowledge that people have in their head, as in I have done this before, so trust me, I can do it again, or a Word document that probably no one actually reads. By moving towards a CD flow where things are automated, we reduce the risk of humans introducing error, not maliciously. In most cases, humans are not bad people. They're just fallible, and we hate repetition. But it also helps us reduce the miscommunication of change. So that's probably the bigger one than actually, the people that know how to do the process and know how to deploy an app are usually pretty good at it. There's a class of personality that survives well in an environment that's heavily repetitive, and they're usually very good and details-oriented around delivering that. The challenge at times is actually the intention of the humans directing that group and the communication that needs to be given to them to say, deploy the latest version. Well, which latest version? This latest version or that latest version? Well, the same one that was there. We remove the ambiguity out of the human language by moving it to a coded, the system will deploy version 23 and version 23 is version 23. If there isn't a version 23, it can't deploy it. 23 has been deleted because we know it was bad because some process picked it up and got rid of it, it can't deploy it. But a human might go, oh, maybe he meant 22, or maybe he meant 24. There's all those opportunities for interpretation. So we reduce the delivery risk. This is the one I love the most, though. To encode the process, we need to know the process. So this is actually the challenge. This is the hard part, because you can sit down and go, we want to get from A to F, but what are the steps along the path? Do we actually know what are all the steps that we do? Do we clear the cache before we run this deployment or after that deployment? At what phase do we remove the node from the load balancer to be able to add this in? What happens if this process is still running at the same time? There's a whole bunch of usually learned behavior that the humans doing deployments and sort of CI review workflow around know innately because they've learned it from failure. Once we start to hand these workflows over to the robots, they won't learn at the moment. We'll probably need to build maybe some ML deployment tools. But they won't learn from failure. They'll just continually try the same broken process over and over and over again. So we need a way to be able to actually understand the process, understand the failure, and feed that back in. But it also helps us once we've got that confidence. So once A plus B equals C, if all the tests are passing and we know the deployment will work because it's been tested, what's actually stopping us from releasing? And this is often the brain fuck for a large amount of organizations is but someone hasn't checked it. But I can show you the only diff that's been made was to remove this piece of CSS from that file. We know that what's in production and this is only diffed by that. And we know the workflow will only do these steps. And we verified that the outcome that we were expecting this CSS change to do has been applied. What's stopping us from releasing? Why do we need to go through a manually exhaustive exercise of investing time? That's the harder cultural change to get people to actually believe and trust in the system. We do that through this. We do that through better visibility on change. So when everything, the system, the mechanism by which the change is applied and the change being applied is version controlled, we can be very open and transparent with what's happening. We don't have to say, oh, we know Mike is going to run the right version of this deployment tool, or we know that Joan is going to use the right version of the application, or this patch that we just manually go onto a server and we apply 15 times over, we know it's okay because we know that all the production servers are in an exactly identical state and this change is going to work perfectly on every single one of them because we don't patch in production. When we remove all of that, because we've got that visibility, we can start to show people to say A plus B equals C. We know what our current state of all of our systems are at any point in time. We know whether all of the tests have passed. We know what production's like. Realistically, we can get the hell out of the way of the business value and just let stuff actually be deployed. It leans really well into regulated environments, so where there are audits and compliance requirements that are needed. If you actually have been through any of that audit stuff, what you'll find a lot of it is based on a whole lot of trust of humans. We have controls in place that make sure you are skilled to be able to do this with varying levels of validation on that. We end up with a whole lot of bureaucratic complexity around separation of concerns and independent people, but 14 keys that all need to be turned at the same time to make sure that all of the intention is correct. Once we have a visible codified pipeline and workflow and assets that can be easily inspected, we can say to the auditors, tell us what we're doing wrong. Let's sit down and walk with you and understand how we've been able to implement the controls that you need to give you the visibility, to give you the confidence that we're actually doing what's expected. And of course, we get efficiency. So if we can deliver things with reduced effort, then we deploy things more frequently, which gives us greater feedback, which allows us to experiment faster, which hopefully leads us to doing things in smaller batches, which gives us an overall increased flow in the system. This comes back to the whole lean approach of identifying and automating waste. So if we invest in a fully automated end-to-end CI workflow, when things go wrong, because they will, because we don't actually know what the process is, because our system hasn't gone through the 13 years of learning of the human that's done this forever, who knows all of the little weird things that you've got to stop the second server before the first server because of some reason that we don't really understand why. When we've done this repetitively, we either get the opportunity to work out why that was the cause and fix it, or we can encode it into the practice so we never have to forget it ever again. Because then when we learn from failure, we can do these things. And the whole purpose of these systems is to allow us to move faster and move at a rate of knots that increases our confidence with what we're doing on a regular basis to deliver value to our customers and ensure that, as I said, we get out of the way. If the IT and technology teams can get out of the way and let the business realise their value, we'll all be having so much fun.